In this video I'm going to go over a series of examples that are covered in Chapter 6. These are the last two pages of the notes from section 6.3. So the first question is to simplify 2 sine 15 degrees cosine 15 degrees. If we notice that this is of the form 2 sine theta cosine theta, well, 2 sine theta cosine theta is the double angle formula for sine. So this is sine 2 theta. So what we have here is 15 degrees is what theta is going to represent. So theta is 15 degrees. So the left side, we would say 2 sine of 15 degrees cosine 15 degrees. And this is going to equal sine of 2 times 15 degrees. Well, 2 times 15 is 30, so we would say this is sine of 30 degrees. Sine of 30, well, 30 degrees is on the unit circle. Sine has a value of 1/2 here, so this would be what 2 sine 15 degrees cosine 15 degrees would be equal to. The next question says to simplify 1 minus 2 sine squared of negative pi over 8. This is in the form of 1 minus 2 sine squared theta is equal to the double angle of cosine. And what we have here is theta is equal to negative pi over 8. So if we were to substitute this in for theta, we're going to have 1 minus 2 sine squared of negative pi over 8. Well, we know that that is equal to cosine of 2 times negative pi over 8. Well, cosine of 2 times negative pi over 8, 2 times negative pi over 8 is negative 2 pi over 8, which we could write as negative pi over 4. So we're going to have cosine of negative pi over 4. So negative pi over 4, that is on the unit circle. If we have a negative angle, remember we start at the point 1, 0, and we're going to go in the opposite direction. So right here would be an angle of negative pi over 4. That is coterminal with 7 pi over 4. In degrees, we could write this as negative 45 degrees or 315 degrees. So all of these angles are equivalent to each other. What is the cosine value at this position? Well, the cosine value, cosine is going to be positive there, and it's going to be root 2 over 2. So what we would ultimately say is 1 minus 2 sine squared of negative pi over 8 is equal to positive root 2 over 2. The next example says to find the exact value of cosine of 105 degrees. So 105 is not on the unit circle, so we need to write this either as a sum or difference of something that is on the unit circle. We could also use a half angle here. So 105 we could write as 45 degrees plus 60 degrees. That would work. A couple other examples, or a couple other angles we could use. We could use 135 minus 30 degrees. That gets us 105. We could use let me write it like this. We could use 105 and do a half angle here. 210 divided by 2 is 105 degrees. So these are a few of the options. There are certainly more that we could choose from. I'm just going to use what came first to my mind. So remember, cosine of A, since I'm saying 45 plus 60, we're going to use the sum formula. That should be B. Cosine of A plus B is equal to cosine of the first, cosine of the second, change the operator, sine of the first, sine of the second. And we are going to say that A is 45 here, B is 60. All right, so cosine of 45 times cosine 60 minus sine 45 sine 60. cosine of 45 is root 2 over 2. Cosine of 60 is 1/2 minus sine of 45 is root 2 over 2. Cosine or sine of 60 is root 3 over 2. Multiplying these two together, we get root 2 over 6 minus root 6 over 2, and that is going to be root 2 minus root 6 all over 4. This example says to find the exact value of sine of negative 5 pi over 12. So similar to that last problem, we want to come up with two angles on the unit circle that either add up or subtract to negative 5 pi over 12. And we could use 3 pi over 12 minus 8 pi over 12. Now it might not seem like those are on the unit circle right away, but if we reduce, we're going to have pi over 4 minus divided by 4, we get 2 pi over 3. Okay, a second way we can tackle this problem is if we take the angle, negative 5 pi over 12, we could convert that into degrees. So negative 5 pi over 12 times 180 over pi. And if we do that, well, I can divide each of these by 12, and this is 15. We get negative 75 degrees. The whole reason to do this is because it may be easier for us to see a sum or difference that adds up to negative 75. And one example would be 60 minus 135. We could also say 45 minus 120. These are possibilities. And again, it doesn't matter which of these three options we use. I'll use the first one, but any of those options that we used, they would give us the same value at the end. So this is sine. I'll write out the difference formula here. And we're using the difference formula because all of these options I came up with are differences. So we're going to say sine of A cosine B minus sine B cosine A. And I will let A equal pi over 4, B equal 2 pi over 3. We're going to have sine of A, so sine pi over 4 cosine 2 pi over 3 minus sine 2 pi over 3 cosine pi over 4. Then we just evaluate each of these using the unit circle. Sine of pi over 4 is root 2 over 2. Cosine of 2 pi over 3 is negative 1/2 minus sine at 2 pi over 3 is positive root 3 over 2. And cosine of pi over 4 is root 2 over 2. Multiplying these first two together, we're going to get root 2 over 4, and that's going to be negative, minus root 6 over 4, and then we can combine those. That will be negative square root 2 minus square root 6 divided by 4. So this question, as with the previous question, we can check this on a calculator. If we were to type in sine of negative 5 pi over 12 in radian mode, because that angle is in radians, we're going to get a decimal approximation, and that decimal approximation is about negative 0.9659, and if we type in this fraction, we're going to get the same decimal approximation. So that tells us our work is in the right place. This example asks us to verify the identity. There's a couple ways that I see to go about this. On the right hand side, we could change all of this in terms of sine and cosine. One thing I see right away that I'm going to do is this right here, sine of x plus y, well that's just the sum of x plus y, or the sine. So what I'm going to do is I'm going to apply the sum formula of sine here. So sine of the first, cosine of the second, plus sine of the second, cosine of the first, divided by sine x, sine y. I'm not going to do anything yet to the right hand side. And then what I'm going to do is I'm going to split up this fraction into two separate fractions with the same denominator. So sine x cosine y over sine x sine y plus sine y sine x, oops, that should be cosine x over sine x sine y. And the reason to do that is because sine x and sine x will cancel here, and then sine y and sine y are going to cancel here. And what we have left is cosine y over sine y. Well, that is just cotangent of y. And then here we have cosine of x over sine x. So that is cotangent of x. And that's exactly what we have on the right hand side. I'll write this in the same order. And that's it. And then this final example is another identity to verify. Tangent squared of theta minus sine squared theta is equal to sine to the fourth theta times secant squared theta. What I think I'll do is convert this tangent squared into sine squared over cosine squared. And then I'm going to get a common denominator here. So let's move that equal sign. What I'm going to do is I'm going to multiply by cosine theta over cosine squared theta over cosine squared theta. The reason is now I will have a common denominator between the two terms on the left-hand side. So we have sine squared theta minus sine squared theta cosine squared theta divided by cosine squared theta. Let's see, now I'm going to try to factor out the sine squared theta here and see what that does. We have sine squared theta times 1 minus cosine squared theta, and we get cosine squared in the denominator. And this expression right here, this is equal to sine squared. And the reason is this comes from one of the Pythagorean identities. Right? If we subtract cosine squared from both sides, we get sine squared. So on the left-hand side here, we're going to have sine to the fourth theta over cosine squared theta. And then what we can do on the right-hand side is, well, I have sine to the fourth theta, which occurs on the left. And then secant squared, well, secant is just 1 over cosine. So secant squared is 1 over cosine squared. So when I multiply those fractions, or those factors together, we're going to get sine to the fourth theta over cosine squared theta. And that will do it.